blow up, I think. There's a pool of water, very shallow, about 6 meters in diameter, and then in the center, like the pupil of an eye, is a very, very dark, deep pool, about 1.5 meters in diameter. It's black, and the water in that is swirling around. The steam is rising very fast. The water is churning. That's what they call this, the churn, or strokka. That's the name of this particular feature. There's lots of other people standing around with cameras poised, waiting for it to explode. Whoa! There it goes. That's about 50 meters into the air. Great big giant shoot straight up. Wow. That deep dark hole in the center is emptied. It's now filling up again really, really quickly with a gorgeous blue water. And now it's full again. Ready to churn a little bit more for another few minutes before another explosion. Wow. Just shot straight up. That pool in the centre formed a bit of a dome for a split second, and then boom. There it goes again. Wow! Straight up. Suddenly you get this sort of impetuous bubbling of water, and then poof. And then the puddle's filling up again. Wow. Well, here I am, Adam Smith, right next to the Strokka geyser. I'm here in Iceland to find out what is going on underneath the Earth's crust here. Welcome to Pod Academy. If there's one man who can answer probably all of my questions about what's going on in Iceland underneath my feet, he's here, in this building very close to the harbour side, in a small fishing town called Stykkishólmur, a couple of hours' drive north of Reykjavik. This building is painted red, the colour of lava. Let's go inside. Hello, Haraldur.
Yeah.
I'm Adam.
Oh,
Nice to meet you.
nice to meet you. Well, I'm Haraldur Sigurðsson, and I'm born here in Stykkishólmur. And I have been a professor of geology in the United States for about 35 years, and I've carried out research on volcanoes all over the world. West Indies, Indonesia, Italy, Africa, and elsewhere.
Why is Iceland so volcanic?
Well, it sits on top of the Mid-Atlantic Ridge, where the plate boundary occurs, and also it is a hotspot. It's an area in the upper mantle where there is a greater degree of melting than in the rest of the mantle. So it does get more magma to the surface than most other parts of the world, or all of the parts of the world. So that's why it's so especially volcanic.
Yeah. I went to the geyser the other day, and Strokka.
Yeah.
It was very, very impressive to me. We don't have anything like that in England. Can you tell me what happens there?
Well, the geyser is a type of a hot spring. There are a number of those in Iceland. And we have different types of hot spring areas. We have low temperature, which is in 100 degrees or less, 100 degrees centigrade, or we have high temperature areas that are 200 to 300 degrees centigrade. And in any way, in the geyser, there's a cavity within the earth, or with a few tens of meters or 100 meters down, and the water collects in that cavity. That's because of its depth, it's under pressure. The water is increasing in temperature, and it reaches a boiling point. But because of the pressure, there's a certain amount of superheating that occurs, and then the water begins to rise, and then the pressure decreases, and then all of a sudden you get flash boiling. So you get a lot of gas formation, or steam formation, and that ejects a column of water out and forms the geyser. Then the cycle starts again.
That's good for the tourists.
That's right.
Just from your long time looking at volcanoes, have you ever been worried when you've been standing next to a volcano? Have you ever been scared?
Certainly, yes. There are many instances when I've been working on a particular volcanic eruption that you're close to the volcano or on the volcano, and you have to be very careful and take precaution. So yeah.
What sort of precautions can you take?
Get away. Stay far away.
Yeah.
But then, of course, your curiosity draws you near, and you also may be involved in some measurements or some program of analysis or sampling that brings you close in. So you have to make a judgment as to how close you can go and how long you can stay near in that area.
Is there any particular time when, at a specific volcano, where you've been in that dilemma of curious but also scared, and you've had to make that decision?
For example, on the volcano called La Soufrière in St. Vincent in the West Indies in 1979, I was on the volcano when pyroclastic flows started to be generated.
Is that the big cloud of ash?
Ash and gases that flows down the flanks of the volcano like an avalanche, except it's 200 degrees temperature or more and moves very fast. And fortunately I was on ridges that were higher than the flows, so I was safe. On the same volcano, in 1971, I was working on the crater lake, and all of a sudden the crater lake started to boil, and a new island formed in the crater lake, and I went out with a boat onto the lake to get samples from the island when the lake was 93 degrees centigrade, so that was scary. So yeah, there have been cases like that, but it's part of the job.
Yeah.
And I continue to do that, but in my spare time I'm running the Volcano Museum in Stykkishólmur.
And it looks like you have someone who you need to ask for a admission price.
Myndaðilega bannaði kannski. Eru svona bannaði? Nei. Það ekki bara flash. Nei, ég ekki að taka myndir. Þú mátt taka mynd.
So, what have you built here?
Well, the Volcano Museum is housed in a more than 100-year-old building here in Stykkishólmur, and it houses the collection that I've acquired over 40 years from all over the world. It's an international collection of art and items that relate to important volcanic eruptions. That's kind of how I started with the art, because I started to see in old eruptions that had taken place a long time ago, where we didn't have any photographic material, had very little documentation, but you often had some art. And in the art you can get an idea of what's going on. On the bottom we have two illustrations of Krakatau volcano. One shows the volcano before and the other one after the eruption of 1883. And so it gives us a lot of information about that from the artwork.
Right, because
so we don't have photographs, but we do have good artwork.
The top one shows sort of perfect mountain, if you like, and then the bottom one shows that it looks like it's had the top lopped off. Yeah, it's collapsed.
It's collapsed. So so that's a very important feature. That's how I started becoming interested and started to collect this in a way. The artwork ranges from 1500s to the 21st century. There's quite a bit of emphasis on Iceland, but also on Italy and Indonesia, the Caribbean, Mexico, Japan, and it's it's an international view of how artists have seen volcanic activity through the ages.
So is it more of an art gallery or a museum?
I don't like to be pigeonholed in that sense. I think that the beauty of it is that it doesn't really fit into any simple description.
Can you show me a couple of your favorite pieces then?
Well, this piece here is our oldest, and it's from 1551. It's from one of the earliest books published, and it shows Hekla volcano erupting in 1551.
Hekla in Iceland.
Hekla in Iceland. And of course, at that time, Hekla was very important in the Middle Ages because it was believed that it was the gateway to hell. And so there's a lot of mythology about Hekla. And here's another view of Hekla up here, which shows the Hekla volcano, when it erupts, often splits along its length with a 3-kilometer long fissure that opens up and erupts along its length.
And there are three plumes coming
right,
from.
then you get 3 craters, and finally usually one that is active. But it starts with a long curtain of fire in the eruptions.
How active is Hekla today?
It erupted in the year 2000, and it's an active volcano, but it's not erupting right now.
Could it erupt anytime soon?
Oh, yes.
Could you tell me about this one? This is the nearest to where we are, right?
Okay, well, yes, this is Snæfellsjökull, the volcano, the most famous volcano in Iceland, probably, but certainly the most famous volcano on the Snæfellsnes Peninsula, although it's not the most active one. But it is it's an unusual volcano for Iceland because it's conical shape. Most of the volcanoes in Iceland, the big ones, are elongated like an overturned boat because they're built on fissures, but this one is built on a circular conduit or pipe, and so it has this perfect conical shape. And because of that, there's a lot of attraction to people and kind of magnetic landscape.
And because you grew up here, presumably this was one of the first volcanoes that you started to
well,
look at?
Well, not really, because there are volcanoes just outside town. There are so many on this peninsula. So I started to look at some ones that are much closer by here. But certainly was one that was important.
What do you think drew you to them? Why were you so interested?
Just the general landscape. It becomes, when you start to travel in or walk around to hike in the area, then you immediately see the great landscape, and you start to wonder about what created it, and so you want to study it, and so one thing follows another.
Do you remember how old you were when you first?
It's probably in my early teens.
Yeah.
Mm-hmm.
And did you just go and walk around them and have a look?
That's right. Yeah. And we have kids like that today. There's an 11-year-old boy who comes in here regularly just to look around, and he brings in rocks, and he's got his own ideas about what's going on, and so it's great to see kids taking interest in that.
Yeah.
And it's kind of a natural thing when you live in this type of environment.
Could you tell me more about this map here, because this is where we are now,
yeah, well,
and it's sort of about 4 or 5 meters long, and it looks like it's detailing all the different kinds of rock.
Yeah, the idea is to offer here information for visitors to this Snæfellsnes area. Snæfellsnes is a volcanic zone that is quite different because it's perpendicular to the other volcanic zones in Iceland, and But it does have this, in a small area, you have all of the geologic formations you have in the rest of Iceland, very accessible. And so what we've done here is we've, in addition to the geologic map, we've identified 62 localities that are the most interesting localities in this region, and explain on these iPads in pictures and maps and text the main features of each one of these 62 places for visitors to research before they go out in the field.
This must have taken a lot of work to put this together.
Yeah, that's right. It took a lot of work, and we're going to put it on as an app, so you can go out there in the field and you can look it up.
How many people worked on this?
Just two of us.
Really? Just two?
Yeah, I did all the composing of the text and gathered all the photos, and then I got a designer to do the layout.
Let's carry on. I was wondering whether you could tell me a little bit more about in this cabinet here.
Well, this is Indonesia. Indonesia is the most volcanically active part of the earth, with 150 active volcanoes, and there's always an eruption going on. There's some at any time, every day.
So even right now, any time?
Yeah, every day, yeah. And so we have, in this collection, we have a focus on Tambora volcano that erupted in 1815, and that's the biggest volcanic eruption on the earth. And that we measure the size of the eruptions by the volume of magma that is produced, and we measure that in cubic kilometers. And this eruption produced 100 cubic kilometers, and it led to immediately to a death of 120,000 people in Indonesia. And it also led to a global climate change because of the gases that came out that produced a big aerosol cloud, a veil all around the Earth that backscattered solar radiation from the Earth away from the Earth for about 3 years, causing global cooling. So that's a very, very important eruption, and I've done a lot of work on that.
Yeah, what work did you do there then?
Well, I did the field work on the area to establish the distribution of the deposits and determine the volume of the deposit, how much came out, and also the mechanism of the eruption, the style of the eruption. So there were many aspects of that. So I spent many years working on that.
When were you there?
I started working there in 1986, and I've been working there up to a couple of years ago.
Really? Just going back every so often?
Well, every so often, yeah.
Yeah. What effect has that eruption had on the people who are still there?
Well, there were virtually no people left.
All right.
And so new people came into the area. The area was abandoned for several years, and then new people settled in, and they had really no information or no idea about the volcano or what had gone before. So there was kind of like a clean slate.
When you go and do some work in a place like that, do you feel that you're more a historian or a geologist?
Well, you're really more a geologist, but it's a matter of time scales, because you're dealing with the geologic process, but it's occurring in recent time, so it is documented to some extent in historical records. So it's you kind of mix history and geology. Basically, you look for all information you can get, whether it is from the layers in the earth or from books or publications or whatever sources.
From one of the world's most famous volcanoes to Vesuvius over the other side, which has to be one of the other ones as well.
Yeah, this is all Vesuvius in this area here, and that's a very, very important volcano.
Why is it so important?
It's closely associated with the history of volcanology. Some of the earliest studies were done in Vesuvius, some of the earliest ideas about volcanism. Of course, the Pompeii eruption, or the eruption that destroyed Pompeii in 79 AD, is a very classic example, because that's the first eruption that is described by an eyewitness, where we have documentation. And the many aspects of Vesuvius that are important is, for example, here's an image of Vesuvius from 1638.
It's a cross-section. You can see inside the volcano.
This is a scholar, Athanasius Kircher, who was a Jesuit priest in the Vatican, and he wrote a book called Mundus Subterraneus about the volcanoes, published in 1638. And in it he had this view of Vesuvius, and he's the first one to make a cross-section, and a revolutionary idea. And he shows it like an oven inside.
Is it scientifically accurate?
No, it's not. That was the general view then, that volcanoes were like a furnace. But we know that's not true. We know it's magma or molten rock inside. But he also is the first to make a section of the entire Earth, as you see in that lower diagram. So they're of historical significance as advances in thinking.
This one
not necessarily advances, but at least reflect the state of thinking.
Yeah. So you can track through history your predecessors in your field, if you like, and see how the thinking has changed. This one, the volcanoes on the surface of the Earth, they all open up, and then there is this great network of paths inside the Earth.
Yeah, that was the general view at that time. Well, that's what he was proposing.
Yeah. Are there any Icelandic volcanoes on this picture?
Well, this is purely a schematic, so it's not meant to reflect any particular volcanoes, but rather just a kind of a schematic of a cross-section of the Earth.
I wanted to ask you about this one. There's a sort of very modern feel to it. It's got this sort of newsprint background and then this great wash of red ink over it, forming the shape of the volcano and the magma flow, presumably. Who's this one by?
Well, Andy Warhol. That's
really?
An Andy Warhol original. And he's, of course, very famous as the father of the pop art movement. And he did that in 1985 when he was in Italy for 5 months.
And he's more famous for soup cans and things than volcanoes,
well,
right?
Only one. He only did this one. But in 1985, of course, Vesuvius wasn't erupting, but he makes an eruption, and he uses the eruption of Mount St. Helens in the United States in 1980.
So that was just a few years before he made that.
A few years before, and he used this eruption as a basis for reconstructing the Vesuvius eruption, and he did a terrific job on that.
Can we go around the other corner?
Sure.
You have a great long table filled with lots of different rock samples.
That's right, yeah. They're all the rocks of Iceland. There are not that many rocks of Iceland, rock types.
Right.
And they're all large, and it makes a very different impression. In most museums you've got little pieces, but once you make them nice and big like this, it's more of an impression, and also you can't carry it away with you.
That's true, you can't steal them, they're too heavy. But you can touch them as well.
Yes, that's right. People like to touch them and roll them around, and it makes a big difference. You kind of get a feel for it. So it's a very good teaching tool. We don't want to make it too complicated. We have explanations of all of the rock types here on the board, and make it obvious.
What's this bright red one?
Well,
it's a gorgeous colour. It's the colour of your building, in fact.
That's right, yeah. It's called Pompeii red, this colour, by the way.
Oh, that's the name?
Yeah, the colour.
Yeah.
These three here are jasper, and jasper is not volcanic, but it's a rock made by hot spring activity. And so it's silica, 99% silica. And it's formed when hot water comes up fissures, and the hot water carries a lot of silica, and then the silica is precipitated on the walls of the fissures and gradually closes the fissures. and leaves the silica behind and makes jasper, which is this. And the trace of iron will give it the color, the red color. So that's...
But the other object there, the other rock there, is the same, but it's blue. It's a different colour.
Well, I would say that's green.
Green.
Okay. It may be a trace of copper or manganese that'll give it the green colour.
Yeah.
But they only need that's less than 1% to... But otherwise it's all silicon.
Yeah.
Mm-hmm.
I've seen lots of this everywhere in Iceland.
This is andesite. This rock here is called andesite, and it's an important rock in Iceland. Maybe 10% of the rocks in Iceland are of that composition. Another 10% are rhyolite, and then 80% basalt.
Basalt, yeah, I've seen
the most common rock. Yeah.
This looks like an aero chocolate bar to me. It has all the bubbles.
That's right. That's from the top layer of the basalt, from the top part. So the top will have there's a lot of gases in the lava when it's flowing, and the gases are forming bubbles, and they rise to the surface, and they form this. And then it solidifies and preserves the gas cavities.
I see. So that's why it looks like an aero chopped through.
That's right.
Just finally then on the museum here, why did you choose to situate it in Sigurðsson?
Well, this is where I was born and where I grew up, and so I wanted to bring it here.
And
nothing else.
And what do you hope that it will achieve?
Well, I hope it will act as an interface between the scientists who acquire the knowledge and the general public.
Well, he'd be a pretty good guest to have at a dinner party, wouldn't he, old Haraldur Sigurðsson? What an amazing project to found this museum just a couple of years ago, to bring together all sorts of artworks, sketches, engravings, screen prints with rocks and things that he's collected from volcanic eruptions and from history. That's rocks, that's pottery, that's stalactites, it's all sorts of different things, and to bring them all together in the same room I think is an absolute master stroke, because what it does is it says these are all part of the same conversation. The rocks are not stuck in a lab or behind a glass case, accessible only by scientists and geologists in white gloves, and equally the artworks are not stuck in a stuffy white-walled gallery looked on only by art critics and curators. They are all part of the same phenomenon, which is people looking at volcanoes, looking at mountains that explode and thinking, well, gee, that's really interesting. I want to think about that and interpret that in some way. Now, if you're a scientist, you're going to look at magma formation or the compositions of the different rocks that the volcanoes spew out. And if you're an artist, well, you're going to sit there and paint it. But it's all part of the same thing. It's humans looking at their environment and thinking, wow, this is pretty special. I'm going to somehow record it and think about it. Now, the job that I have the rest of my stay here in Iceland is to make sure I can survive without getting swallowed up by an earthquake or ignited by some lava flow or consumed by a pyroclastic ash cloud. I can see mountains in the distance with snow or glaciers on them and cliffs much nearer by. And is that grey smoke rising from one of those hills over